Electromobility is booming. Everyone's talking about chargers, car production, and the shift to zero-emission transport. But there's one major issue that's barely mentioned. What happens to EV batteries when they die? Where will the millions of used packs go once they leave the roads? This problem is coming, and it won't be small. How many batteries are we talking about? Today, there are more than 20 million electric vehicles on the road. By 2030, that number is expected to exceed 200 million. By 2050, it could approach 1 billion. Each of those vehicles has a battery, and each battery will eventually become waste. This isn't science fiction. It's the near future. How long do EV batteries last? Most lithium-ion batteries last between 10 and 20 years. It depends on driving style, charging cycles, and cell quality. After 10 years, batteries typically retain 70 to 80% of their original capacity. But for many car makers, that's not enough to keep the battery in use. The battery is removed from the car, but that doesn't mean it's dead. Quite the opposite. It begins its second life. The second life of EV batteries. A retired battery can still serve a purpose. It can be used as energy storage for solar panels, in homes, businesses, or as a backup power source for hospitals. In Japan, some hospitals are already powered by used EV batteries. In California, they help stabilize the electric grid. Renault and Nissan repurpose batteries from their Leaf models. This second life can last another 5 to 10 years. But even that ends eventually. And after that, recycling begins. Recycling means dismantling the battery and recovering valuable materials. Lithium, cobalt, nickel, copper. Without them, we can't build new batteries. The problem? Recycling is complex, expensive, and still underdeveloped. Traditional pyrometallurgy offers only 50–60% efficiency, but modern hydrometallurgy can recover up to 95% of metals. Redwood Materials in the USA and Umicore in Belgium are building new recycling plants. How many plants will we need? By 2035, the world will need dozens of facilities capable of handling hundreds of thousands of tons of batteries annually. Europe currently recycles about 200,000 tons per year. Asia is ahead. China handles over 1 million tons. North America is around 140,000 tons. But it's not enough. More batteries are hitting the market every year, and the old ones don't disappear. What if we fail to handle it? Imagine mountains of old batteries. They contain toxic materials. Leaks into soil and groundwater are a real risk. And without recycling, we lose access to key resources. We'll have to mine them again, at a huge cost, both financially and environmentally. In Congo, cobalt mining is tied to child labor. In South America, lithium extraction consumes entire water reserves. Recycling is a way to break that cycle, but we're barely using it. What's the bottleneck? Recycling is technologically difficult. Every battery is different chemistry, structure, and form. There's a lack of standardization, a lack of global coordination, and a lack of time. Many countries support EV expansion, but ignore what comes after. It's like building houses and forgetting to plan for garbage disposal. Are there new technologies? Yes. Startups around the world are developing more efficient recycling methods. Hydrometallurgy, cell reassembly, automated battery disassembly. Germany's Karlsruhe Institute developed a non-burning process that recovers up to 70% of lithium. Tesla plans to recycle 100% of its batteries inside its own gigafactories. The European Union passed new legislation requiring 70% recycling efficiency by 2031. What's happening already? Redwood Materials recycles batteries for Ford and Toyota. Norway's Hydrovolt processes batteries from across Scandinavia. In the USA, gigascale recycling plants are under construction. In China, old batteries are used as backup power in high-rise buildings. Germany runs a program that uses second-life batteries for grid balancing. But all this covers only a fraction of what's needed. We're still in the pilot phase, and the wave is already coming. What's next? We must build a global recycling network, enforce take-back systems, and scale fast, or we'll face a new kind of environmental waste. EV batteries won't disappear. Their numbers will multiply every single year, and every unresolved battery will become a future problem. Summary: the EV transition isn't just about what we build today. It's about what we dismantle tomorrow. Batteries will reach the end of their life, and we need to be ready. This is the biggest challenge the electric revolution still has to face. And the solution? We need to start building it now. Subscribe our channel and hit the like button.